All right, folks, we are going to start section 7.7, where we're going to factor polynomials in the form ax squared plus bx plus c. So in 7.6, the a value was always 1. Today, it's going to vary, and it's not going to be 1 all the time. We're going to have 2 learning targets. The first is that you're going to be able to solve real-life problems, and that you can factor and solve polynomials in that ax squared plus bx plus c form. Okay, now on the next couple pages, we actually have just, again, another activity that we had went through. I'm assuming that you've already went through that in class, so we're just going to jump right to the notes, which is going to be on 7.7, page 4. Okay. In 7.6, you factor polynomials of the form ax squared plus bx plus c, where a is 1. Okay, to factor polynomials in the form ax squared plus bx plus 1, where a is not 1, first, always look for a greatest common factor of the polynomials, and then factor further if possible. So remember, greatest common factor is going to be the largest number that evenly divides out of every number. Okay, and that could be a variable, and that could be just regular old numbers. So as I look at this, 5x squared plus 15x plus 10, what I like to do to check for the greatest common factors, I like to look at the smallest number. Smallest number is 5, and factors of 5 are going to be 1 and 5. Knowing this, I want to check all of these numbers and see if they divide out of everything. So I'm going to check 5. Well, 5 divides by 5, 15 divides by 5, 10 divides by 5. So that means I have a greatest common factor of 5. So what can I do is I can actually undo the distributive property by factoring a 5 out like such. Okay, so then to figure out what's going to be left over if I divide a 5 out, 5x squared divided by 5 would be 1x squared. 15x divided by 5 would be 3x. 10 divided by 5 would be 2. Okay, so then now what you want to check is that changes my a value. So my a value went from being 5 to now being 1. So I can check my a value is 1, b value is 3, c value is 2. Okay, and my method of factoring when my a value is 1 is just the regular old X method, where you check your a times c value and your b value here, get a 3 here and a 2 here. And you check for numbers that multiply to 2 and add to 3. Well, then it's going to be positive 1 and positive 2. All right, so what does this factor into? This factors into 5, original greatest common factor, times a factor of x plus 1 times a factor of x plus 2. So all we're doing is layering the types of problems we have to do, greatest common factor, then factor again using the X method. Okay, so now we're going to do the same thing with letter 1b. Okay, we're going to check for a greatest common factor. Again, I'm going to check the smallest number. So I'm going to think about my factors of 3, 1 and 3. And really the only number I need to check is 3 to see if a 3 divides out of each of these. 3 is a factor, 9 is a multiple of 3, and 6 is a multiple of 3. So that means there is a greatest common factor of 3. So what am I going to do is I'm going to divide out of 3. 3y squared divided by 3 is y squared. 9y divided by 3 is 3. And 6 divided by 3 is 2. So this problem almost turns into the exact same thing, because once I divide that 3 out, my a, b, and c values are the same. A is 1, b is 3, c is 2. Since my a value is 1, I can use the X method of factoring, where I go a times c down here and b here. And what do I have here is I just check for numbers that multiply to 2, add to 3. We did that in the previous problem. It's going to be positive 1 and positive 2. So then this is going to factor into 3 times y plus 1 times y plus 2. So this is almost the same problem, but I think it's neat how they can kind of be the same problem, but they look vastly different from each other because one's multiplied has a greatest common factor of 3, one has a greatest common factor of 5. Okay, let's take a second and work on the next 2 problems. So pause the video and then move down to monitoring progress 1 and 2. Unpause it when you're ready to see how you did. Okay, number 1 and 2, monitoring progress. Okay, so you do a little bit of work here and you're going to find that there's a greatest common factor of 4. When I divide a 4 out, I'm left with p squared plus 8p plus 15 is that number. Okay, so then now my A, B, and C values have changed because I've divided a 4 out. So my A value is 1, my B value is 8, and my C value is 15. Set up my X. A times C is 15, B is 8, and numbers that multiply to 15 and add to 8 are going to be positive 3 and positive 5. So this is going to factor completely into 4 times P plus 3 times P plus 5. Okay, on monitoring progress 2, you got to check for common numbers that divide out of everything again. You do a little bit of work and you're going to find that a 2 divides out of everything. So I'm going to divide a 2 out of this and I'm left with u squared plus 5u plus 4. Okay, then now my A value 1, B value 5, C value 4. Set up my X, A times C is 4, B value is 5. Numbers that multiply to 4 and add to 5 are going to be positive 1 and positive 4. So this is going to factor into 2 times u plus 1 times u plus 4. And I'm done. All right, so that's what it looks like when you take a greatest common factor out. Now, what you want to check for every time is a greatest common factor, because they don't all have the same pattern where you greatest common factor and then it's X method. Because today what we're going to do, as you should have done during the tile activity that we did here, is we're going to deal with what happens when the A value is not 1, even after a greatest common factor. And so we learned in that activity that there's 2 components, X and then box. So we're going to elegantly name this method the X box method, because we're going to use the X that we just previously did, and then plus the box, which would be like undoing the box method of multiplication. So what do I have here? I have a 3-term polynomial, and I want to check for a greatest common factor. Okay, when I'm checking for a greatest common factor, I'm going to look at the smallest number, and the factors of the smallest number are 1 and 3. So I'm checking 1 and I'm checking 3. So I'm going to check 3. Yes, 3 divides by this. No, this isn't. 3 doesn't divide by that, and neither does, and 1 divides out of everything, but that's not going to change the problem. So my problem has no greatest common factor. So I'm going to do my A value, which is 4, my B value, which is 13, and the C value, which is 3. So as we discussed at length during the activity, the real hard part is figuring out how to break up my 13 X's, because we're going to have a box here. Okay, we're going to have a box here with my 4y squareds here and my 3 here. And it's just a matter of how do I split these 13 y's up? And as we learned in that activity, it follows the exact same process of A times C and B, which is very convenient for us because it just gives us a nice solid routine to work from. So here, A times C is going to be 12 and B is going to be 13. So now I'm going to need to find numbers that multiply to 12 and add to 13. And those combination of numbers is going to be 12 and 1. So if I were to split this up with the box method, okay, our factors, this is what we're going to get. So now what we have to do is try to find the greatest common factor. Okay, so to find the greatest common factor, it might help to find all the factors. So I'm going to do this one time, and this will be the last time I do this. And then 12 has 1 and 12. 2 and 6 and 3 and 4. So this is what you can do if you really struggle with your facts and you're not really sure. You need to find the greatest common factor. So what I did for the first couple here is I found all the greatest common factors. I'm going to do 4 right here also. Okay, so now what I'm going to do is I'm going to look at 1 and 3 and I'm going to ask what's the greatest common factor, meaning what is the biggest number in the list of all the factors? Well, the biggest number here is 1. So the biggest number that divides out of 1 and 3 is 1. Okay, so then, I mean, it's the largest number in each list. So this is what you have to do if you struggle to not know what the greatest common factor is. Okay, so let's go this direction. What about 12 and 3? So as I look at this, 12 isn't going to be it. 6 isn't going to be it. 4 is not in the 3 list, but the 3 is, and so is 3. And that's the biggest number in each list. So the greatest common factor going this direction is going to be a positive 3. Okay, now what we're going to do is we're going to do these two between 4y squared and 12y. So we have the biggest number here is 4, and 4 is also in this list. So the greatest common factor is going to be 4y. Greatest common factor between 4 and 1 is 1, and then y because they each have a y. So if I were to box method multiply this out, 1y times 4y is 4y squared, 1y times 1 is 1y, 4y times 3 is 12y, 3 times 1 is 3. So this works. So what does this factor into? It factors into 4y plus 1 times y plus 3. So again, we're going to be finding the greatest common factor quite a bit through this section. And if you struggle with that, you might need to list all of those factors until you find the greatest one. Okay, so that is 2A. Let's go ahead and do 2B. Okay, the process is the same. We want to check for our greatest common factor. And our greatest common factor, we're going to check 2. Well, 2 divides out of 2, but it's not going to divide out of 7 or 3. The only other factor of 2 is 1, and that isn't going to do anything. So no greatest common factor. So A value is going to be 3, B value is going to be -7, and C value is going to be 2. Okay, so then what I need to do is I'm going to create the X first so I can figure out how to split up my X's, or my -7X's in the middle. That's the part that is to be determined. So we're going to set up our X, A times C and B, which is -7, and 3 times 2 is 6. Okay, so then just like we did in the previous section, we need to start thinking about what kind of numbers am I going to have? Numbers that multiply to a positive and add to a negative is going to result in 2 negative numbers. Okay, so 2 negative numbers, a negative times a negative is a positive, a negative plus a negative is a negative. So factors that multiply to 6 and add to 7 are going to be 1 and 6. So now when I set up the box, I now know how to split those up. So I'm going to put a +2 here, -1x here, -6x here, and then 3x squared here. Okay, now the next thing I need to think about is I know I have negatives here and a positive here because I'm going to have a negative times a negative. So since I'm going to have a negative times a negative, I'm going to have negatives in each of these corners here. Because I know a negative times a negative is going to be a positive. Then I can start taking greatest common factor. What's the largest number that divides out of 2 and 1? Well, it's 1. What's the largest number that divides out of 3x squared and 6x? Well, 3 and 6, the largest number that would divide out of that is 3. And then x squared and x is also going to be x. Okay, 3x squared and 1x. Largest number that divides out of each of those is x, or 1x. And the largest number that divides out of 6 and out of 2, the greatest common factor of that, would be 2. So my answer is going to be 3x minus 1 times x minus 2. And again, you can check this really easily. 3x times x is 3x squared. 3x times -2 is -6x. -1 times x is -1x. -1 times -2 is +2. Okay, and then now at this point, it's just the process kind of repeats itself. Okay, the hardest part is just thinking about the negatives. Okay, so here, greatest common factor, there is none. So now what I'm going to do is set up my x, a times c, and my b. A times c would be 2 times -7 is -14. My b value is -5. So here I'm multiplying to a negative, but I'm adding to a negative. So it might help to think multiplying to a negative and subtracting to 5. When you do that, you're going to end up finding that's -6 and +2. Okay, so if you're struggling filling out the x, you might want to go back and watch the 7.6 video where we go over that in more detail. So then I set up the box. Okay, we're going to have a 2b squared here. We're going to have +2b, -7b, and then -7. Okay, so now what you want to think about is where am I going to take a negative out at? Well, I know I'm going to have a positive times a negative to get this, and I'm going to have a positive times a negative to get this. So logically, it just makes most sense that I'm going to have a positive up here and a negative down here. Now you just check for greatest common factor. The largest number that divides out of 7 and 2 is 1. And again, if you don't know that, if you were to set up lists of the factors like this, you would just look for the largest number in each list. Greatest common factor between 7b and 7 would be 7. 7b and 2b squared would be 1b. 2b squared and 2b would be 2b. So this is going to factor into 2b minus 7 times b plus 1. And again, checking your work is very easy. Okay, now the only thing, and it's not that it can't be done, on 2D that's different from the other ones, is that my a value is negative. And we have yet to deal with a negative a value. So what we're going to do in that time is we're going to start by taking out a greatest common factor, and that greatest common factor is going to be -1. Okay, so when I take out a greatest common factor, I divide out a -1, and I'm going to be left with 4d squared plus 8d minus 5. So now that has changed my A, B, and C value to the point where my A value is going to be 4, my B value is going to be 8, and my C value is going to be -5. Okay, so now I can set up my X in my box and see now my A value is negative or is positive. And it's not that you can't deal with it when the A value is negative. It's just that it's easier when it's positive. And we have means, what I just showed you now, dividing out a -1, that will always allow you to keep your A value positive. So A times C, 4 times -5 is -20, and B value is 8. Numbers that multiply to -20 and add to 8 are going to be +10 and -2. Then you set up your box. (4d squared minus 5), and this will be 10d, and this will be -2d. And then where's my negative going to come out? Right here. So the greatest common factor here, 5 and 2, would be 1. Greatest common factor between 5 and 10 would be 5. Greatest common factor here would be 2d. And greatest common factor here would also be 2d. So my answer is going to be 2d plus 5 times 2d minus 1. All right. And that is it for the Xbox method. Really, there's nothing extra we're going to add to that. Okay, so if the A value is negative, take a greatest common factor out of -1 and then start your factoring process. Okay, you should know the routine by now. Go ahead, pause the video, and then work on monitoring progress 3 through 6. When you're done, check it back with me, and let's see how you did. So I'm assuming that you've already taken the time to do these problems, and now let's see how you did. Okay, first things first, we want to check for a greatest common factor, and this one has one. It has a greatest common factor of 8, and so when I factor out an 8, oh, that's 7. This is what you get. Hey, this problem got a lot easier because my A value is now 1. So my A value is now 1, my B value is now -7, and my C value is 6. Since my A value is 1, I don't need the box. I only need the X, which again makes it easier. So you're looking for numbers that multiply to 1 times 6 and add to -7. Those numbers are -6 and -1. So this is going to factor in 8 times x minus 6 times x minus 1. Okay, number 4. Number 4, you're going to check again for greatest common factor. So a number that divides out of all of these. And, 31, I believe, to be prime. So this is just going to be what it is. So the A value is 14. The B value is 31. And the C value is 15. Okay, so you got to set up your X. Okay, and 14 times 15, I believe to be 210. So A times C, and my B value is 31. Now, this might be a problem where you have to go and list all those factors until you find them. 10 divided by 1, then divide by 2, then divide by 3, et cetera, until you find the combination. That's your backup plan if you don't know. This one, to me at least seems a little bit obvious. It's 10 and 21. Okay, a value is not 1, so I do have to use the box. Okay, so I am going to kind of show you how to, these numbers are a little bit bigger. So I am going to show you what you can do if you really don't know the greatest common factor. So greatest common factor between 10 and 15, you just list all your factors of 10. And then all your factors of 15. And what's the biggest number in each list? Well, it is 5. So we can take a 5 out. Okay, greatest common factor of 21 and 14. So here's 21. And here's 14. And again, you're looking for the largest number in each list here. Largest number in the list of 21 and 14 is 7. So this is going to be 7Q. Here, you're going to look this direction and you're going to look between 14 and 10 and find the biggest number in each of those. And it's going to be 2. So this will be 2Q. And then 21 and 15, which will be 3. Okay, now you can go back and check. If you know this is 5, you can problem solve and probably figure out that that's 3 because 5 times something is going to have to give you 15. But this always works as well. So my final answer is going to be 7Q plus 5 times 2Q plus 3. And that's my answer to 4. Okay, number 5. Okay, number 5 here. Check for greatest common factor between 2, 7, and 5. I don't believe there's one. So I can just set up my X in my box. A times C, 2 times 5 is 10. B value is -7. So you're going to look for numbers that multiply to 10 and add the -7. That's going to be -2 and -5. Okay, when I set this up, I'm going to have a 2u squared and a 5, and then have a -5u and a -2u. Okay, I have negatives in each of these corners, but I'm multiplying to a positive. So that means I'm going to have negatives in each of these corners. Then you take the greatest common factor. Here's 5. Here's 2u. Here's 1u. And here's 1. So this factors into 2u minus 5 times u minus 1. Okay, last one on this page before we try the word problem. Number 6, you're going to check for greatest common factor. 4, 19, 5. There's no greatest common factor there. So then what I'm going to do is I'm going to set up my X. A times C is -20. B is -19. Numbers that multiply to -20 and add to -19, that's going to be -20 and +1. Then you set up the box. So you're going to have 4y squared, -5, -20y, +1y. Okay, we're multiplying to a negative here and here. So that means my negative number is going to be right here. Then greatest common factor, same thing over and over. Biggest number that divides out of each of these is 5. Biggest number that divides out of each of these is 1y. Biggest number that divides out of each of these is 4y. Biggest number that divides out of these is 1. So this is going to factor into 4y plus 1 times y minus 5. All right, so that's the Xbox method of factoring, okay? So right now we have 3 different methods of factoring. Greatest common factor, we worked on that today. X method of factoring, worked on that today. Xbox method of factoring, we also worked on that today. So those are kind of the 3 main ones. There is one more, but it's shockingly similar to what we're going to do here. So really make sure you have the Xbox method of factoring it down. It uses a lot of skills throughout the whole chapter. Okay, let's go ahead and work on the word problem here. Okay, the length of a rectangular reserve is 1 mile longer than twice the width. So I'm going to draw a thing. I'm going to draw a little diagram here. Okay, so we are going to say that this is the length and this is the width. And it says that the length is 1 mile longer than twice the width. So if the width is X, then the width, but it's twice the length of that. So is one long. So if the width is X, okay, we're saying that that has a distance of X because we don't know what it is. The length is going to be 1 mile longer than twice the width. So twice the width would be 2X, but 1 mile longer than that, it would be 1. So for example, if this was 2, this would be 5, because 2 times 5 is, or 2 times, I misspoke. If this was 5, this would be 11, because 2 times 5 is 10, 10 plus 1 is 11. Okay, and then it says the area of the reserve is 55 miles, square miles. Okay, so we have an area formula here where I'm going to go length times width. We talked about how area and quadratics are very closely related. We know that the area is going to be 55 square miles and that the length is 2x plus 1 and the width is just x. So this is an area formula that we can solve. But if you remember using the zero product property, it has to be equal to 0. So I have to unfactor this by using the distribution property. And now I can set it equal to 0 by minusing 55. Okay, now that I have it set equal to 0, the next thing I want to do is check what's the greatest common factor. 2, 1, and 55. There's nothing that divides out of each of those. So what you're going to do is we're going to use an A value of 2, a B value of 1, and a C value of negative 55. So now we have to think about, since my A value is not 1, I have to use the X and the box to factor this. So I'm going to set up my X. Negative 55 times 2, I'm just double checking this because this is actually the first time I'm working through the problem, is negative 110, and my B value is 1. Ooh, so I got to think a little bit about this. Numbers that multiply to 110 and add to 1. Oh, okay. So this is going to be positive 11 and negative 10. Going to double check that. 11 times negative 10 is negative 110, and negative 11 minus 10 is 1. Okay, for you, again, you might have had to make that little T chart and list all the combinations, 1 and 110, 2 and 55, 3, 4, et cetera, et cetera. Then once we do that, we can set up the box. So this will be 2x squared. This will be negative 55. This will be 11x, and this will be negative 10x. Okay, so then here we have to find the greatest common factor, and negative is going to come out here. This one's easier. The biggest number that divides out of 11 and 55, that's just going to be 11. Biggest number that divides out of 2x and negative 10x would be 2x. That would be x, and then this would be 5. So now I'm going to just shift my paper over a little bit and finish my work up here. I have x minus 5 times 2x plus 11. Equals 0, and we have to use the zero product property. Again, zero product property means I have one number, x minus 5, times the second number, 2x plus 11. I'm multiplying them together. My answer is 0. What does that mean? That means one of those numbers is 0. Okay, so here we have x minus 5 is 0, and then 2x plus 11 is 0. So then what do I have to do? I have to solve each of these. Well, so that means x is either going to be 5 or minus 11. 2x is equal to negative 11, and then divide by 2. X is equal to negative 5.5. Now, both of these are algebraic answers. Only one of them is going to be the real answer. We've had this happen before. So you have to think about what makes the most sense in the context of the problem. Does it make sense for me to have a width of negative 5.5 when we're talking about a mile reserve? No. So that means this is my answer. So what is the width of the reserve? It is going to be 5 miles. Okay, it doesn't make sense to have a negative distance there. Okay, at this point here, I think it's best that you pause the video and go ahead and try to solve monitoring progress number 7 of the day. Okay, so I'm assuming that you paused the video and you've tried it. So we're going to do the same thing. We're going to start from scratch, even though this one could easily have just replaced a number. So what is the area of the reserve? What if the area of the reserve is 136 miles square? Well, our diagram's the same. We know that the length is going to be 2x plus 1, and the width is just going to be x, and that the area is going to be length times width. Now, instead of 55, the area is 136. Otherwise, everything here is going to be the same. Again, can't solve these problems if it's equal to 136, but you can solve it if it's set equal to 0, because you can use that powerful property, the zero product property. So that's exactly what I'm going to do. I'm going to distribute the x, get 136 is equal to 2x squared plus x. And then I'm going to set it equal to 0 by minusing 136 from both sides. Okay, there's no greatest common factor. My a value is not 1, so I have to use the Xbox method of factoring here. So here I'm going to go 136 times 2, negative 272. And my b value is 1. Okay, so I got to think what that's going to be. You know, honestly, I don't know. So I think we're going to have to go 272. We're going to have to start listing these. Okay, so obviously 272 divided by 2 is 2 and 136. Okay, 272. I'm going to divide it by 4 because I know 3. Okay, I think I got it. 272 divided by 16. 17. So I'm going to do a little bit of work here, but then eventually you'd get to 16 and 17. Okay, so we're going to get to positive 17 and negative 16. Okay, so again, it helps when you're good with your facts, but I just demonstrate what exactly you can do one by one until you find that combination. If you're not as good with your facts, which happens from time to time, but at least you have the problem solving skills to figure it out. So now I can set my box up. So here we're going to have a 2x squared, negative 16x, positive 17x, and negative 136. So here I got to find the greatest common factor. I do know that this is going to be negative. Let's check if 136 divides by 16. It does not. Okay, so now what I'm going to do is I am going to check 136. I'm going to divide it by 8 because that's the next biggest factor that divides into 16. And I get 17. So that looks like the biggest number here is going to be 8. And the fact that I know that this is 8, this is going to have to be 17. Because 17 times negative 8 is going to have to be negative 136. So that's how you can problem solve through some of these tougher problems. Okay, here greatest common factor is going to be x, and here the greatest common factor is going to be 2x. So now that it's factored, I can use the zero product property. 2x plus 17 times x minus 8 equals 0, which means 2x plus 17 equals 0, or x minus 8 equals 0. So first one, I would minus 17 from both sides to solve to get 2x is equal to negative 17. After I get the 2x by itself, I'm going to divide by 2 and get x is equal to negative 17. That should be negative 8.5. Okay, and then this one will be a lot easier to solve. You just plus 8. And then you have to ask the same question that we answered in the problem above. Which one makes the most sense in this problem? Does it make sense to have a negative 8.5 mile reserve width? Doesn't. It really just doesn't. So what does that mean? Although these are both algebraic answers, this is the only one that makes sense in the context of the problem. So what's the width of it? The width of the thing is going to be 8 miles.